بسم الله الرحمن الرحيم والصلاة والسلام على نبينا محمد وعلى آله وصحبه أجمعين. Okay, so today we're going to start first lecture about introduction to AI and data science. And inshallah today I'm going to introduce several of the terminology that we talk about in AI and data science and give you just a brief overview about the landscape about the data science world. So what is data science? Can everybody just tell me what do you think about data science? Yes.
It's the use of algorithms, mathematics methods, just to capture some data.
Capturing some data. Okay. It goes beyond this, beyond capturing, but it's partially correct. Yes.
Using methods like analytics to process data to make value of them.
Processing data. Yeah. So capturing is collection, and also processing is part of the data science, right?
Finding patterns, collecting data and studying it to find patterns.
Exactly. Yes. So pattern recognition and identification, right? Yes.
Is it like what the data that is coming, what exactly it's about? Or what do they know?
Yeah, data exploration is one of the things. This is what we call data exploration. And we process the data to even get more insights and also perform decisions. Yes.
So it's the science of analyzing data into visualizations and insights.
Visualization is also a very important part of data science. Yeah, so you pretty much said everything about data science. That's pretty much correct. And now data is like, yeah, I'm going to give you a talk next time. Yes.
But sorry, can you upload the slides so we can write notes?
Okay, yeah, I will do. Yeah. Okay. So data is considered today as the new oil. You know that the oil is like the backbone of the life right now. Okay, fueling, electricity, every energy is coming from the oil. And data is like the new oil of today because with data we can have knowledge and we can take informed decisions. And informed decisions, this is like the first key for successful efficiency in companies, in enterprises, in government, in every kind of businesses and societies. So there is another terminology coined by Andrew Ng. Andrew Ng is maybe one of the most famous AI and data scientists in the world. He mentioned that AI is the new electricity. Okay, so it's same analogy as the new oil. It's basically now the backbone of the life of all type of businesses. Everything is based on the data. But the data by itself is like the raw oil. You cannot do anything with the raw oil. You need to process the raw oil in order to get benefit of it, making as a fuel for cars, for vehicles, for airplanes, or for making energy. So same thing, data science is actually the science that allows you to take benefit of that new oil, of the data, okay? And we need to process this data to be useful because the raw data is huge. Now we are in the world of big data, and big data is any kind of data like audio files, text files. If you have a huge amount of data, it's difficult to get insight of this data if you don't have the right tools to process it. And this is why now we have, and we can even go beyond this, like making prediction of what could happen in the future based on the history of data. This is like the essence of machine learning, and later on it has evolved to deep learning, and now we are in the era of generative AI. It's even able to generate content based on prompts or based on the user intention. And actually the next future level of AI is what we call general artificial intelligence, where artificial intelligence not only can do specific tasks, but it can do any kind of tasks. So now the scientists are working on materializing the concept of general artificial intelligence. And ChatGPT was like the triggering point about general artificial intelligence because ChatGPT is almost the first tool that has the capability to do plenty of tasks. It can do now pretty much everything: text processing, summarization, translation, now generation of pictures, of images, interpretations. You know, it's kind of very fascinating world. And so data science, basically, as already mentioned, is the overlap of several disciplines, basically computer science, mathematics and statistics, and also the business knowledge. All of them combined, they form the world of data science. So we talk about statistics, machine learning, data engineering, feature engineering, domain expertise. And the challenge here is that the data comes of different types and shapes. It can be structured, like for example, databases. Okay, in databases you have structured tables. Your data is very well known in advance. You have very clear structure. And there is unstructured data, which constitute like the majority of the data that you can find on the internet, like for example, audio files, images, Word document, Excel sheets, different type of documents. And there are different tools that we use in data science. As already mentioned, the mathematics, probability, and statistics is like the pillar of data science, because we don't have certitude about this data. So the best that we can do about this data is to understand the trend of the data, okay? To have a holistic view about the data, and we can have kind of certitude when this data is very large. So we're going to review this concept later on when we have a refresher on probability and statistics and the law of large numbers. When you have a huge amount of data, you can actually have more certitude about what this data about and how we can interpret this data in more accurate manner. Programming. So during this course, we're going to use Python programming with different type of tools like Matplotlib, Seaborn, NumPy for linear algebra, Pandas for structured data, like tabular data. We're going to also use machine learning when we talk about predictive models, how to do regression, how to do classification. Don't worry about these terminologies. We're going to go into all kinds of details in future lectures. So deep learning. So the difference between machine learning and deep learning is a subset of machine learning that uses neural network to make prediction as well. It can do classification, regression, but it's based on neural network, which is a type of perceptron that perform linear and nonlinear activation functions to process the data and make predictions. And also we can do analytics, where we can use Power BI, Tableau, or the different tools like Matplotlib and Pandas to visualize the data and make better insights out of the visualizations. So for data analytics, there are three different types. Descriptive analytics, and this is basically what you have done in probability and statistics. You have the data and then you calculate the average, the standard deviation, the confidence interval, the percentile, the box plots. So this is what we call descriptive analytics, because it allows you to describe your data. For example, if I have several grades of the students, I will do the average to have an overall performance about the average performance of the student. So this average is going to describe a certain tendency of the performance of the students. But not all the students will have the same average. Some will have bigger values and some will have lower values. So there is kind of variance between the students. And there is another metric that is called depth variance that will tell me how close the students' grades are close to each other. So if I have a big variance, it means students have completely different performance. There are very good students and very bad students, or very low student performance. And if the variance is very small or standard deviation is very small, I can understand that the student's performance is close to each other. So in these type of ways, we can understand the behavior of our data using descriptive analytics. And this is an essential part before going into any kind of data science project, is to make a descriptive analytics. Even if your ultimate goal is to do predictive analytics, you need to understand your data first to take the right decisions. And we have predictive analytics. It means what will happen in the future. And I already explained yesterday that now we can have certain amount of historical data that if we process it in the right way, we can actually predict using some predictive models what could happen in the future. Okay, for example, and this is done basically in marketing and business, for example, to study the consumer behavior. Okay, so if I have some attributes about certain consumer, for example, his age, his gender, his city, this type of information, it can allow me to predict whether the consumer is likely to purchase this product. Okay, that's one of the things that we can do with machine learning and predictive models. And there is also prescriptive analytics. What should we do next? So if I did predictive analytics, it means what are the actions that I have to take okay, in order to, based on the predictive analytics or on the descriptive analytics. So for example, making recommendation or optimize the business practices and to suit the multiple predicted values. So what is the data science process? Now, if you do any kind of data science project, you have to go through a life cycle. And the first thing in the life cycle is to understand your business, what you'd like to achieve. So if you have a raw data, you don't jump directly into processing the data, but first of all, you may discuss with the stakeholders, with the customer, what you'd like to extract from this data. So you have set of requirements that you need to achieve. And later on, you will study your data. So if you have already data collected, you will check whether this data is sufficient to satisfy the business requirement, or if it's not sufficient, in this case, you can actually require to collect extra data. Sometimes, some businesses, they may have some objectives, some requirement, but they don't have the right data to achieve this objective. So you can't do just any kind of processing for data, but the data must be aligned with the business requirement. So the first thing, you need to understand the business. You need to understand what you want to achieve, identify the problem that must be considered in the study, and then you jump into the data acquisition, data collection, capturing. For example, you can ask a company, give me the records of your database, or if you're working on video files or images, or depending on the objective of your study. So the data, usually when it comes with too much noise. Imagine that you have a database, let's say of students. You can find missing information. You can find wrong information. For example, the names are not correctly written, or maybe some information like birth date is missing from some people, or I don't know. So it's really important first, in the third step, to clean your data. Okay, you need to deal what I should do, for example, with the missing data. Should I delete the whole record, or replace the data with the different values, or just put the data to 0 if it is an integer? So there are plenty of techniques that we are going to study when we talk about Python for data science, on how to clean the data to maintain the consistency of the data and the study. If you have too much noise, if the noise is 50%, 60%, whatever processing you will do, you will not be able to extract a correct information. Right? Okay. So handling missing data or fixing any kind of inconsistency. The fourth thing, after I clean my data, I have now data that is ready to clean, is feature engineering. So not all the data is equivalent to the objective of the study. Okay? For example, if I want to calculate the student behavior, and I have in my data student names or birth date, probably the student name and birth date, mobile phone are not relevant. They are not features for that particular study. Maybe for other studies, but for that particular study, they are not relevant. So I'm going only to keep the data that will pretty much related and tied to the objective of the study. And this is what we call feature engineering. Feature يعني خصائص. استخراج الخصائص. Yes.
Isn't that part of cleaning the data?
Hmm?
Isn't it about cleaning the data?
No, cleaning data, usually it's the data itself, but it's missing some, probably you have missing values, probably you have wrong values. Okay, so this is what we check. And now if your data is clean, you need to extract only the columns, the features, or the attributes that will serve the purpose of your study. And this is what we call feature engineering, or sometimes feature extraction. Okay, so transform your raw data into relevant and meaningful features. Sometimes we just delete unwanted columns or unwanted data, and sometimes we need to do some transformation. Maybe from the grade, I'm going to calculate the average of a grade and put this as a new feature. In some other context, I will make some data transformation in order to create another type of data. So there are different type of things that we can do for feature engineering. And now, once our data is ready for being processed, so we can do predictive modeling, or maybe descriptive modeling. Usually we can do descriptive modeling even during feature engineering, just to understand the different trends of the data and their distribution. And predictive modeling is, you need to build model, train model. This is what we call supervised learning. Supervised, it means we're going to use the data and the corresponding output to guide or to train a new machine learning model. And of course, predictive model in the beginning, they will generate you erroneous predictions. So we keep optimizing them, evaluate these models until we can get a satisfactory prediction. Of course, there is no 100% of prediction accuracy, but we try to be as close as the 100%. Okay, in some cases, 80% is a good number. In some other cases, we need to reach 90%, 95%. It depends on the context. Okay. So one of the things that we do for predictive modeling is sentiment analysis. Okay, you know, many people write in Twitters about a certain topic, and we want to know what's the overall sentiment of people. Are they happy or not happy? So now there are some sentiment analysis techniques that is able to understand whether a certain statement is positive or negative. So we can do predictive model. We're going to collect a huge amount of data as text written by people on Twitter, on social media, and then we're going to train a machine. If you receive this sentence, this is positive. If you receive this sentence, this is negative. And from thousands or millions of sentences and extracted text from the internet, we can actually build a model. When you give a new sentence that was not seen before in the model, it's able to give you with a good accuracy whether the sentiment is positive or negative. This is one of the predictive models that is very popular in NLP and also artificial intelligence. And once you get, so you build your models, you need to evaluate your models. So we have recourse to data visualization. Okay, we can make plots, heat maps, histograms, box plots in order to visualize the data and illustrate it to the stakeholders. So this is basically the workflow that we need, that we usually follow. That's basically the same thing. It's the data science process, data collection. And when your model is fine, okay, and you want to make it for business, so you will deploy it into the cloud, and you can expose it as an API for others to consume it or to integrate it into your business process. So let me give you a few examples. Now, this is a simple data that is collected from one of my courses, okay, and I want to do a course data analytics. And this is very basic, and we can do with any kind of tabular data or CSV data like this. So first of all, what do we identify here? Okay, can we directly jump into processing the data? So I can find that some values are missing. Okay, and this is now we are in the step of, so the first step is business understanding. I want to take some information about the behavior of the student in my course. So I collected the data during the semester. This is the data collection. And now we are in the step of data cleaning. Okay, data cleaning, it means I'm going to try to find a solution with this data. So I have two options. One of the options is to remove the whole row. Is this feasible in this case? No, because I'm going to lose the information of complete student. Second option is just to put some values to this one. So maybe if I consider that the student is absent, I can put 0. Or maybe try to find maybe it was missing and it's some. So I need to do some solutions to here. So basically we can put them to 0 or put them to another value if the grade exists somewhere. And after this we can do what we call the EDA, the Exploratory Data Analysis. And this is the descriptive analytics. Descriptive analytics, for example, I can check the distribution of grade for the major exam, for the final exam. I can see what is the concentration of grades. For example, this is the first, this is a quiz, this is the total score distribution, so I can find most of the students are in the middle. I can also use box plots, we can use heat maps, so there are different ways on data visualization. And you're going to learn about all of this in Matplotlib and Python and the different tools for visualization in data science. And of course, we can extract a lot of insight. So look, from raw data like this, we can derive these charts and figures, and then we can explain the behavior of these figures. Okay? And here, the heat map, what does it do, the heat map? What kind of information you can extract from the heat map? The correlation between the exams. For example, here I would like to see the correlation between the first quiz and the final exam. So if I find good correlation, it means students who perform well in the first quiz will have a tendency to perform well in the final exam. So to 70% or 60% or something like this. Okay, it's not very readable, but usually I do this to check the relationship between the different type of exams, and because usually I want to have some early information about the students' performance from the first assignment or from the second assignment, what could be the future behavior of the students. Okay, so the EDA, the purpose is to understand the data characteristic before doing any modeling. Okay, before doing a machine learning model, I need to understand what is the distribution of my data. This is very important, and later on when you go into practice, you will understand why this study is really needed in advance. So the technique are descriptive statistics, like doing the mean, the average value, the median, the variance. We can use data visualization, making scatter plots, box plots, as already mentioned. Correlation analysis using heat maps, and we're gonna use different type of tools like pandas, matplotlib, and seaborn. And this is one of the things that I've done last year in CS102. So I wanted to study the correlation between the student performance in my course and their performance in CS101 course and the correlation with their GPA. So you can see, for example, here there is strong correlation between the GPA of the student at the entrance and also the grade of the student in CS102. And I find out that the relation between the GPA and CS102 is stronger than even with CS101. So this gives me some insights, because now when we do the grading, we need to have certain distributions, and if the input, for example, for the GPA is not very high, we don't expect to have very strong correlation. So you can see the data is very consistent. Okay, it's not, and this gives you more confidence that students that were with low performance at the entrance, 70%, they might not find themselves easy with the course. Okay, so there is a strong correlation between the different grades, between the English grades, between CS101, CS102 also. We can see here, this is CS101 and this is CS102, 75% of correlation. So students that are strong in programming 1, they are likely to be also strong in programming. It's not 100%, there are some deviations to some extent. Okay, so you can see how beautiful are these tools to give you better insights about student performance, in my case, course analytics, or in any other scenario. Yes?
So how do you calculate the correlation between for example, your grade and a specific course, for example, CS1?
Yeah, there are algorithms on how to calculate the heat map. Okay, it's like a covariance matrix between the different type of grades. Yeah. So box plots shows the distribution of the data. Okay, so if the box plot is very large, it means there is strong deviation between the student performance if it is very close. And look, for example, the difference between software engineering, information system, computer science. You can get different type of insights. That's pretty much amazing, you know, to understand this type of relationship just based on data like this. Okay, so we can transform raw data, like raw oil, into something useful. This is an example of California housing data set also. Usually we use this one as an example to show the prediction of the houses based on some features. For example, if a house is located في حي النداء and has this number of rooms, has this space, we can have an estimate about what could be the reasonable price for that one. We can make prediction models if we have a large amount of data. And of course, before even doing analytics, for example, this shows the distribution of the house cost over all the data set. So that was about descriptive analytics, and we can also do predictive analytics or predictive modeling. For example, here we would like to make prediction of the sales based on the advertisement expenditure. So imagine that there is a company that will spend money on advertisement, and they would like to see how much benefit they will get based on the advertisement, and they have different type of advertisement channels through the TV, through the radio, through the newspaper. And we can see this is the relationship between the newspaper and the sales, and this is the relationship between the radio and the sales, and this is the relationship between the TV and the sales. So what looks as the weaker relationship?
Newspaper, I think.
Yeah, because it's kind of scattered. Look, visually now I can interpret the scatter plot that I can have high expenditure on newspaper, but low income. And just adding a little bit, I can have much higher income. So same thing here. Look, horizontally it's spread horizontally. However, here it's more spread. Vertically. Now it's spread more horizontally. So there is kind of more linear relationship here, okay, which is increasing trend, okay, and this shows like a better relationship between the TV advertisement. So here you can take a decision that probably putting more effort into TV advertisement will be more beneficial for the sale than as in the newspaper, okay. Okay, so you all listen about AI, machine learning, and deep learning. What's the difference? Yeah.
AI it's a general term. I'm not very sure. For the example of machine learning and deep learning, I can drop this one. Machine learning depends on three neural networks, entry, intermediate, and exit nodes, or not nodes, layers of the neural network. Deep learning would have more than three layers of neural networks.
Okay.
This is roughly the idea behind it.
Oh, machine learning basically is not related to neural network, but neural network is one of the things that we can do in machine learning. I'm going to explain this, but thank you for, yeah.
So AI is the general term.
Okay, that's correct.
Contains both machine learning and deep learning. Okay, so machine learning is basically an algorithm that's like put by the developer himself, by the AI engineer. But deep learning is like a machine learning algorithm, but it's iterative, so it kind of works along with neural network. Just and it learns automatically by itself.
Okay.
It's kind of automated.
Yeah, it's correct to a good extent, yes. Okay, so I think there is a consensus that AI is the general term. So AI is basically quite old, since the 50s of the 19th century. Okay, 1950s, artificial intelligence started basically with search algorithms, constraint satisfaction problems, solving some typical and early artificial intelligence problems like games. You remember, for example, Deep Blue when has the challenge between Deep Blue and Kasparov in the chess. Okay, this basically they used advanced search technique in order. They didn't use like the current nowadays AI neural network deep learning to solve these problems. And then machine learning. So basically, machine learning, it's the artificial intelligence that is based on the learning, that is based on the data. Okay, so we learn from the data. Of course, there is supervised learning and unsupervised learning, but basically, we're going to use a huge amount of data to learn some patterns. So it comes with pattern recognition. And you can find algorithms like support vector machine, live bias, random forest. These are like the classical machine learning algorithms. And they were used in applications like spam detection. For example, spam detection in emails started from the late 90s, okay, to detect spam based on the email content. And deep learning, this is a subset of machine learning that is based on neural network. But of course, your colleague was kind of right. I mean, if we have a small amount of layers, okay, we don't call it deep learning, but usually deep learning is tied with neural networks, but with large amount of layers. So we have neurons that will process the data, and then we learn from the data in order to detect patterns out of this data, and they are based on neural network. And one of the things that you've mentioned, which is correct, is that in machine learning, we have what we call feature engineering or feature extraction. So in machine learning, the feature extraction is done manually. We're going to manually remove the data that is not part of the features. This is possible, but in very complex problems. For example, you have an image, you have millions of pixels, and you want only to extract the pixels that are relevant to the picture. It's impossible to remove this manually. There are some early manual techniques, but they were proven to be non-efficient. And this is why when neural network emerged with convolution in 2012, and convolution, what it does, it just do automatic feature extraction. It has a picture, is going to automatically extract the pixels that are more representative into the image without manual intervention. And from that time, the error decreased from 25% to 16%, which was the largest error decrease in the challenge of ImageNet due to the introduction of convolution for the feature extraction. Okay, and this is due to the use of neural network with automated feature extraction using convolution. And of course, later on, it has evolved to natural language processing with recurrent neural network, LSTM models, and then transformers, which have paved the way for ChatGPT and large language model that we see nowadays. This is just a brief history. Okay, so what's the difference between machine learning and traditional programming? So in CS101, CS102, in data structure, you usually create a program, right? So you have data, you create a program, and your program will create output. And this is possible when you want to do simple transformation of your data. For example, calculating the average of the grades. That's pretty much simple, okay? And doing any kind of calculation on the data, derivation, or any kind of mathematical formulation. This is something that you can easily do using traditional programming. But if I give you a picture and I tell you, okay, write a program that tells me what is inside this picture, whether it is a cat or a dog or a car or different type of things, it's impossible. And this is why when we do machine learning, it's difficult to write the program. So we're going to learn the program. So how do we learn it? We're going to collect the data and we collect the output or the outcome. For example, I have this picture and I know manually that this picture is a cat. I have another picture and it's a car, and so on. So I can bring millions of pictures of cats and millions of pictures of dogs and so on. Then I train a model to create a program that will make the transformation. So this is why we call it a prediction model, because we are going to rely on some data, and of course, we cannot train on all kinds of data of the world. If you bring trillions of data from a cat, there will be other trillions that are not part of your data. You can take a picture anytime, and this picture will be completely different from all the pictures. So the model will be trained on a sample of data, so later on it can predict on unseen data. And we need to generalize this machine learning program as much as possible so it can make predictions on any kind of unexpected data. You see what I mean? Okay, so this is the difference between traditional programming and machine learning programming. So you're going to learn how you can transform a data set that is composed of input data and output data to create a program which we call the model, the predictive model. And this predictive model will help you later on to bring completely new data, put it inside, and it will provide you an output with high confidence. There is no 100%, but with high confidence. And basically, for example, ChatGPT, it does this, but it's impressively accurate, that it's almost giving most of the time a correct. So you know what it does, ChatGPT? It just generates the next word. You give it a sentence, it will generate the next word after this sentence. How it was able to do that? It was trained on trillions of words, trillions. So he knows, if I have this sentence, this will be the continuation. This is how we train it. If I give you this sentence, this will be the continuation. And you're going to give the continuation word by word. Or we call it token by token. So let's say word, it's easier. Okay? So for example, if I say, I get up early in the morning and what you'll complete?
Wash teeth.
Yeah. I drink some tea, I go to the school, I go to the work, I drive my car. Okay? So it's because basically you have had a lot of context similar to the first sentence I have given. And you know there are possible continuation. All these continuations are correct, but they depend on the context. Okay, so with a huge amount of data, imagine that trillions of words brought from different type of information, from the internet, from codes, from newspaper, from social media, we're going to be able to converge to a machine that is able to generate this correct output, okay, as a text. And of course now we can even, for example, ask the large language model, draw a picture that contains, and you can have your imagination. And it's going also to do the same thing because it was trained on converting a text prompt into a picture. Of course, this is not easy. It's now only the big tech company that are able to train such a huge model, but the principle is the same. The only difference is the amount of data and the computing resources. Okay, but the principle is pretty much the same. So in machine learning, we have different type of learning. We have supervised learning, is when you have both the data, the input data and the output data. As already mentioned to you, I can give a text, and this text is positive or negative. Or a picture, and this picture contains a cat, contains a dog, contains something else. So this is what we call labeled data set. A labeled data set, I know the input and the output. But labeling usually is done manually. And manual labeling is very costly and time consuming. So there are many people that spend the time and the money to do that, but sometimes in your particular context, you're not able to label the data or sufficient amount of data to train a reliable model. So other techniques, they are called unsupervised learning, and they are used in different type of context, is try to find pattern without relying on labeled data. So it's kind of exploration of the pattern. And of course, from one iteration in the other, to the other, they can find different type of patterns. So it's kind of exploration. And we do that, for example, for clustering customer behavior. Okay, imagine that you have a data set that contains several customer purchase records, and you would like to classify or to cluster these customers. For example, likely to purchase, not likely to purchase, based on some attributes. You don't know in advance what are the criteria of the clustering, but this is going to be discovered automatically by the algorithm, okay, to find the best matching that will reduce the error between the elements in the cluster. Okay, this is how it works. This is what we call unsupervised learning. Reinforcement learning, so it's learning through interaction with the environment. And reinforcement learning, this is like how we teach maybe our babies or our children. When, for example, a child does something good, maybe we'll give him a reward. If he does something bad, we'll give him, like, let's say, a punishment. So he will learn that this is a good action, this is a bad action. And in reinforcement learning, this is how we do. For example, self-driving cars, they all were trained using reinforcement learning. How does it do? So usually we have a car, of course, in simulation, because if we do the learning in practice, it's going to crash every time. We're going to have a car, for example, and within an environment, so it can see the environment, it sees that there is a lane, there are obstacles, there is a street, and so on, and it's going to steer some, and it's going to generate some velocity commands. And these velocity commands will be completely random. So when it hits an obstacle, this will be negative reward. When it moves correctly, this is going to be a positive reward. And it will do millions of repetitions. It's like someone will be driving, and you have a mentor telling you, no, this is correct, this is wrong. So with the time, you're going to learn. So this is what we call reinforcement learning with rewards, either a positive reward or a negative reward, until at the end, it will know what are the correct actions that it has to take in order to drive safe. And this is why now we have self-driving cars. They can drive safer than humans. Of course, within a very specific conditions. The condition must be quite similar to the conditions where they were trained. And at the end, the algorithm is going to converge to be able to drive even in unseen conditions. Yes?
Doctor, I want to ask about supervised and unsupervised. So let's say if we have pictures, and we say that this is a picture of a dog and this is a picture of a cat, this is classified as supervised.
Yeah.
Well, if we don't know about the picture and then it explores it, this is unsupervised.
Yeah, if you don't know about the labels.
Yeah,
If you don't about the labels, yes. So this is called unsupervised. And now with the emergence of large language models, it's called self-supervised, where the model is able to label to some extent I'm going to introduce this in the next lecture. But yeah, the two main categories, supervised and unsupervised. And unsupervised is basically to cluster the data into different groups. Okay? Like for example, customer behavior or so on.
So in order to apply unsupervised learning, you should have previously applied supervised learning.
Yes.
You can take objects.
Yes. 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 Okay, so we're going to stop here.